Okay, so thank you everyone for joining this meeting. This is one of our first talks with Data Science Lab at the University of Regina. Uh, Today, we have Dr. Inayat Rajabi. So Dr. Rajabi is an assistant professor of business analytics from Cape Breton University. He's also an adjunct professor at of computer science at Dalhousie University. Um, Dr. Rajabi's research interest has been on data analytics, knowledge engineering, semantic web. He has worked as a data scientist before in reputable companies. He has been a postdoctoral fellow at Dalhousie University. And he's got a lot of experience in terms of industrial and also scientific side of data science. So the talk that he's going to provide to you today talks about the relationship between the data analytics and data visualization. And we're going to have a demo of Tableau and how you could actually apply some of these findings. So I stop talking right now. If you have any questions, please put them in the comment section. And yeah, I think we should be good to go. Anything else you want to, Dr. Rajabi, if you want to introduce yourself, then I'll give the mic to you. And yeah, thank you for accepting our invitation.
Yeah, thank you for having me. And thank you for the introduction. Hello, everyone. As Ali mentioned, I'm an assistant professor of business analytics at CBU, Cape Breton University. I have a PhD in knowledge engineering. I'm teaching data analytics courses, including data visualization at CBU. I'm prior data scientist at Redispace. My specialization is in data analytics, knowledge engineering, and semantic web. Today, we want to talk about data visualization and how we can use data visualization for data analytics. What is the data visualization process? We will talk about graphics and design. What are the standardized design in data visualization? And finally, we will have a short demo with Tableau, depending the time that we have. So I start with the data visualization definition. One professor asked students to define data visualization in a class and collected all the words um, and now you can see the top 150 words from the students' definitions about data visualization, excluding data visualization as the main term. And after that, the professor reduced the list to 40 words. And here you can see information, visual insights, data. And these kind of words are large in the word cloud. And finally, they reduced the size to 5 words to define the data visualization this way. And finally, the definition that the professor presented was data visualization is a visual way to tell a story with data and information. So this is the one of the definitions exists regarding data visualization. Um, but technically, data visualization is a process to create data graphics. Visualization allows people to analyze data when actually they don't know exactly what they should do with the data. There are some tools in data visualization that help people produce graphical representation of data. And in data visualization, the input obviously is data, and the output is information, graphic, and visualization. In between, we have a process, the transformation from data to graphic, right? They basically define 4 steps for data visualization process: understanding data, preparing data, exploring data, and finally analyzing and visualizing data. The first step, we have to understand data before visualizing. The question that you should ask at the first step is, what does your data represent the real world? Who owns the data? What do the rows and columns of your data mean? And what time period is the data from? These are the basic questions that you should ask when you have the data or you collect the data from everywhere. Um, Basically, we have metadata or data dictionary with the data. Sometimes types and semantics can be correctly inferred from the columns that you have, sometimes not. Data metadata must be provided with any data set because it's not obviously clear from the columns and the fields, the concept or semantics. For example, if we have this table of data, when we have season, we don't know what are the data range exist in season or what each column mean, right? So for that case, we should attach a metadata or data dictionary to a data set. Many data, a large amount of data that exists over internet, they have metadata. For example, if you browse Kaggle website, you can see that each data set coming with a metadata or data dictionary. Normally in data visualization, we classify data. Our data is either qualitative or quantitative. When we are talking about qualitative data, we are talking about categories. And when we are talking about quantitative data, we are talking about numerical measurements. There is another classification called the levels of measurement, which determines which statistical calculations are meaningful and can be used as nominal or ordinal, interval, or ratio. So in data understanding, we should pay attention the level of measurement, the type of data that we have. So data is nominal. Most likely, it refers to dimensions, all right? And we have either a string or numbers, but we are talking about categories. But in ordinal, similar to nominal, but we have order here, direction in addition to category, right? And we have interval. The interval scales are quantitative, includes data constructed with equal intervals like hour, day, temperature, something like that. And we have ratio that we have absolute 0 point, and like age and salary, which zero means zero, right? Like the salary. But in temperature, for example, zero, it means something, right? Um, Beyond the level of measurement and classification, we have data types, right? When we have data in tabular format, we have field, and for each field we have a domain, and domain we have the different data types. We have a date time, and one of the tricky parts of data cleaning is date time format. We have numeric data, integer, floating, and double values where we have decimals. We have categorical data or nominal data, which is non-numeric, meaning that the data or numbers can be assigned to categories like holidays or ratings, hotel ratings, or so on and so forth. In other categories, we have booleans, true or false. Our data type might be geographical, that points to a location on a map, for example, countries, codes, states, these kind of things. And we have text, type of data for which we cannot actually perform a standard mathematical calculation on that. We need to leverage other techniques to visualize text data, right? After understanding data, which is very important step, we have a preprint data. According to a study, more than 60% of the data scientist jobs in data preparation. Okay, so structured data should be properly done for easy processing. Sometimes we have to rename the column, change the aliases, checking the integrity of the data. Most of the data structure that we are talking about are tabular formats. So the rows should correspond to observation, columns we have variables or fields. This makes it easier to map data to visual properties. But in data preparation process, we might face several issues, right? We want maybe we want to rename the variables or fields to make the data more meaningful, or sometimes we have missing values, right? We gather some data from surveys or other sources, but we have missing values. There are several approaches that we can take um, to address missing value issues. We can leave the data as it is. Sometimes it's 10% of the data is missing, so we leave it as it is. Sometimes we define a default value for every attribute that include missing value. Sometimes we replace empty fields with value that appears more frequently. Sometimes, let's say we have a salary, 10% of the data is missing. We consider that, okay, the salary is mean of the other salaries of the data. But when we have, I don't know, more than 50% of data missing in one column, perhaps we need to leverage some predictive analytics to determine the value that we want to replace in the missing value, right? So sometimes we use probabilistic, for example, approach to assign a number or assign a value to a field with a confidence level, right? These are all the approaches that we have to address missing value issues. Okay, let's assume that we have a clean data. What's the next step? Exploring data is the next step in data visualization. To explore data, we can use descriptive analytics. Um, with providing information like distribution, minimum, maximum, variance, these kind of things we can use to explore data to find out outliers, for example, or finding correlation between the variables and the fields that we have in tabular format. And finally, when we explore data, we have analyzing data where we visualize data, and after that, we analyze data based on different visualization. We can simply use a histogram, bar chart, box plot, and a scatter plot to visualize data. But there are some rules that we should follow based on the data type that you have or based on your data set. You should select a right visualization for your data set. In the second part, we have graphics. Um, Selecting the right visualization, as I mentioned, is very important. The number of chart choices can distract you from the goal of communicating the data that you have. Each type of chart is designed to show each type of the data in particular way. For example, if you want to use horizontal bar chart, you can use it when you want to rank the data, or you can use line charts to show the time series data, right? So the type of data is limited by type of the type of the chart is limited by type of data that you have. So sometimes your data set includes univariate data or multivariate data, or your data includes countries, geospatial data, or time series. Certain charts displayed comparison, some others show locations, and sometimes we need a guideline. Based on that guideline, we use data visualization or the specific charts. For example, for categorical data, before going through the visualization of each category, let's see what data classification, data graphical classification mean. For example, categorical. Categorical, we mean non-numerical data such as type or like type of movies or type of books. Sometimes we have univariate data, one numerical variable like the book price. Sometimes we have geospatial data. Sometimes we have two or more numerical data and we want to find correlation between the data. And sometimes we have time series um, or text, or sometimes you have network, right? For each category, based on the insight that we want to have in the data, there are limited chart type that we can use. For example, for categorical data, we can use a vertical bar, columnar bar, or horizontal bar. If we are looking into proportion, we can use pie chart. In univariate data, we are talking about one column, one field. So for that case, we can use histogram to show the frequency, or density plot to show the proportion or distribution. When we have geospatial data, we are looking into location, like points on the map, comparison. We can use different map data, right? Like more point map, connection map. When we are talking about relation, we can use a scatter plot or scatter plot matrix, bubble chart, parallel coordinate. We will go through all these charts briefly in the next slides. When we are talking about time series, we have line chart, and we are looking into trends over the time, right? So that's why sometimes we can use a stream graph, or vertical bar chart also can be used when we have categories. Um, for text, obviously, sentimental analysis can be used, comparison, frequency of the words in a paragraph. For example, we can use word cloud, proportional area chart, or we can use bubbles or a score, or even histogram to show the words in a text. For connections, relationships, centrality metrics, we can use undirected network graph, or directed network graph, or diagram. Let's start with simple text. What's the best way to show a simple text or number, right? Let's assume that we want to visualize 20% of the children had a traditional stay-home mom in 2012 compared to 41% in 1970, right? For that one, someone can create a pie chart, or can create a bar chart, for example, for this text. But the simple things that you can do is you can highlight the number that you want to show to the audience, and you can provide a simple text below the number, right? When you have just a number two that you want to communicate with audience, use just number or text directly. Sometimes you want to compare two different things, and there you can use table. But using a table in live presentation is not a good idea. As your audience reads the table, you lose their ears and attention to make your points verbally. Um, why table interacts with our verbal system, we can use graphs or charts which interacts with our visual system. And by the way, we can use chart or graph for different things. And based on context, these words can be used for different charts interchangeably. Let's start with the comparison. Let's assume that we want to compare several categories. We might have some questions like, what is the best? What is the worst? Compared to what? Who's ranked the highest or lowest? How does performance compare to the largest goal? These kind of questions can be asked when we have comparison. One of the graphs or charts that you can use is bar chart, obviously. Easy for our eyes to read. Our eyes compare the end point of the bar chart easily. Obviously, the bar chart should have a zero baseline, and the bars should be wider than the white space between the bars. And there are some tips in the design that we will look into in this lecture. If you want if you want your audience to be able to compare nominal data, a vertical bar chart is one of the choices that you have. Um, I think everyone knows vertical bar chart. Bars are arranged vertically in axis. Each bar represents a category or subcategory. Um, Sometimes we have multiple categories or series of data. categories in bar chart makes the chart complicated. Columnar bar chart presents two series for each category. Use different color shading for each series. Shade bars from lightest to darkest if necessary. Another bar chart type is horizontal bar chart that we use usually for ranking, for example, to show the first places or second place in a category. The best way to visualize in this is doing in ascending ways from descending way from the largest to smallest. And we can put the label of each bar um, inside of the bar. Another bar chart type is stacked horizontal bar chart, shows total across different category. Um,
full logic stuff.
they
How do
can
we
be
send it just
structured to show either absolute value or sum to
going on the scale
100%.
and saying, oh,
It works well for visualizing survey data. When we have 1% and we want to show, for example, if you have multiple choices in the questions and you want to show one category, you can use um, a stacked horizontal bar chart. So this kind of a Likert scale can be visualized by a stacked bar chart. Sometimes in your data, you are looking into what are the highest, middle, or lowest. Is there any something that stands out? Or what does the shape of data look like? For example, you want to see if the data is normally distributed or not. So you can use histogram, for example. Um, it's very important to choose a proper bin of the data, group of the data, adjust the size of the bins to the best reveal the shape of the frequency distribution. Another plot that we have is density plot. When we want to show probability densities or distribution a single value, when the area below the line is meaningful, in that case, we can use a density plot. For example, we want to show a traffic band, or we want to show impressions, for example, in a video analytics platform. Another graph or plot for distribution is box plot. Uh, when we want to see the different percentiles, or we want to highlight the outliers in the data, box plot are the best because it helps us to find out the outliers or the mean value or median value or the lowest or the highest value in a single even column or different columns of our data sets. Um, the next category is proportions. It presents options for displaying individual part of a whole. We have some questions like, what are the parts that make up the whole? Or what part is the largest or smallest? What part are similar or dissimilar to other parts? Pie chart for sure is one of the choices that we have to show the proportion. Um, the slides are subcategory in a single category. Avoid using pie chart if all the slices are similar to each other. These are the situation that we should not use. For example, pie chart when we have a similar slices um, in our categories. Limit pie chart to at most 8 slices. Label directly inside of the slices and use the white space between the slices to improve the readability of the pie chart. Um, Another type of chart that show the proportion, particularly when you have categories inside of the categories, I mean subcategories, then you can show different categories, and inside of each category, you might have other categories, right? But limit the number of subcategory to 4 or to make it less than 5 to again improve the readability in a bar chart. use a stack bar chart to add up 100% to show the relative differences between different quantities that you have in a stack bar chart. One point that can be highlighted here regarding the stacked vertical bar chart when you want to highlight one subcategory in all the categories. The best way to visualize this graph or bar chart is to put the categories that you want to be highlighted at the bottom so that they can be compared to each other and the other category can be gray or inactive. Sometimes we use area chart to highlight the absolute or relative differences. It's similar to area chart or density chart to show the different series and compare different series on top of each other. Um, Sometimes you want to show again the proportion um, among different categories. Tree maps are um, one of the visualization types that we can use. Um, this visualization is very good for analysis, but it's tricky when we want to visualize it in a presentation or something like that, because when we have small categories, then the small rectangles are not visible or readable. Um, so that's why use a tree map in a way that you can show a limited number of categories, or you want to highlight limited number of categories. Donut chart is similar to pie chart. Here we can use subcategories. This type of chart can contain multiple series and subcategories inside of categories as well. Um, Sometimes we want to use um, some graph to show the relationship between data sets. And we want to answer some question like how column X is related to column Y, or is there any relationship positively or negatively between the fields, or what makes one group or cluster different from another. We can use this kind of graphs. A scatter plot for sure is in the top regarding visualizing the relationship between two variables. Um, Used to show positive or negative correlation between the variables. Labeling is very important. Label just the points that you want to be highlighted, for example, in a scatter plot. Sometimes you have more than two variables and you want to show the relationship between the variables in all the columns that you have. For example, numerical columns that you have, you can use a scatter plot matrix where you define the relationship between the um, different variables, for example, using these scatter plots. I use a lot scatter plots when I want to see what are the overall correlation between the variables in a data set. Sometimes apart from finding the relationship between two variables in a data set, we want to show another dimension like category, like proportion or size of the categories. For that case, we can use bubble chart. So bubble chart is the same as a scatter plot, but we have other dimensions. We are adding other dimensions like size or color to show different categories um, or nominal values in our data sets. Um, Sometimes you are looking into clustering data, and overall we want to know that is there any pattern in our data set among the columns that we have. For that case, we can use parallel coordinates, map each column to a number, and we can see that how the number changes over different columns. Sometimes is not difficult to find the patterns when we see there are some between the columns that we have, there are some relationships that can be used, like I said, for clustering. A slope graph, when we want to show only two time series, past or current situation and future, then we use a simple line between the previous situation and current situation, and we connect different timeline to each other. Um, and perhaps we want to show that how every um, percentage or number changes over the time. Is it bad or is it good? Is it increases or decreases the numbers or something like that, right? For example, this example shows the relative changes in employee server categories from 2014 and 2015. On the right side, you can see we highlight, for example, one of the employee groups. Radar charts compare multiple numerical variable. Sometimes we have columns, they are all in the same time, same data types and data range. For that case, we want to see the patterns between the data. For example, it uses, for example, in the healthcare domain, when we want to see the, for example, patient tests. For different tests, we want to see what happens in 2 or 3 times of patient visit, all right? And we can compare them to each other. We can use a radar chart. It allows us to compare the numbers uh, in different categories at the same time. Sometimes it's not easy to visualize our data in the tables because we have large number of rows and columns, and it's difficult to track the numbers in the table cells. We can use colors to show the relationship, for example, between the variables, right? For that case, we can use heat map. Heat map uses table plus color to highlight some of the cells. The individual values are arranged in a table and represented by colors. We can use grayscale or gradient for coloring, and sorting of the variable changes the color pattern in this visualization as well. For example, on the left side, you can see tables. On the right side, you can see the same table, but in a heat map format. And in the right side, you can see that when we see the heat map, our eyes goes here in the dark cells. And in this way, we can highlight what we want to highlight in the data visualization. Um, a small multiples, when we have a series of similar graph, for example, in a dashboard, and we want to see the trends over the time, we can use a single chart, but in different levels to show the changes over different charts. It allows easy comparison by using same scale. It's particularly used when we have same scales in the columns. For example, we want to show the different trends or metrics over the time, right? So for that one, we can use small multiples. Locations, geospatial visualization um, are used when we want to answer the following questions. Where can the most or least can be found? What is the distance from one place to another? Or how does a variable change by location? Choropleth or field maps are used when we want to show a map by different region and colors. For sure, when we create a field map, we should provide a legend to see different region in different colors. Point map is used when we want to highlight some specific locations instead of a region. Too many points can obscure the location. Consider the size of the points and labeling of the points in your visualization. Um, a symbol or bubble map, when we want to show proportion or size of a region. For example, in a map, um, size of, for example, population of the countries, let's say, or growth of, for example, some disease in some countries, we can use bubble map as well. Um, Another type of maps is path map or connection map when we want to show the lines between different points or distances from different points. We can use connection map as well. Sometimes we don't have any borders or boundaries in our map. For that case, we can use geographical heat map or isoplyph, which shows the gradual changes over geography. For example, when we want to show the temperature um, over different regions, we can use this geographical heat map. Another category is trend when we are talking about time series. How does time of year affect sales? What times are the most popular or something like that? For that case, line chart for sure is one of the choices that we have. Um, Sometimes we want to show different metrics in a same graph. For that one, um, just show four or fewer series of lines in a line chart um, to make your line chart readable. Label each series directly or use an ordered legend in your data graph. Um, Line charts are most commonly used to plot continuous data. As you know, there are two types of charts. We have standard line chart and a slope graph that we talked before. Area graph, similar area chart where the area below the line is meaningful. Um, a stream graph when we want to show a different data series over the time again. Um, and when covering different area are important, for example, in our data, um, we can use a stream graph. For text, we can use word frequency. For example, how many times does a given word or phrase appear? What words appear together? Word cloud for sure is one of the choices that we have. Um, the size of the word shows the frequency most of the time appears in the text. For example, in a paragraph or a document, we want to see the terms or the words that appear most based on the frequency. But if we want to show the words in a document based on different metrics, we can use proportional bar bubble area chart that that in different categories we can visualize the term and highlight it, for example, with the size of the bubble to show some specific metric. For connection and networks, when we are talking about connection from one point to another, we can use, um, like I said, um, network graph, or we can use maps um, that we connect different points of the um, graph in on a map. When we want to show the relationship between the nodes, we can use um, network graph. Network graph can be undirected when the direction is not important in a graph or network. Another thing is we can highlight the lines in a network diagram, and the thicker line, for example, shows the relationship type of the relationship between the nodes. And sometimes the direction of the nodes are very important. For that case, we can use network graph. Um, we can use visualization for different purposes, but there is no best visualization in the context. We cannot say this is the best visualization. It completely based on the type of the data set, the data type, the number of columns that you have, and the goal of your analysis. So based on your analysis, you might use animations, right, in the design. For example, we want to show the trend over or the metric over the time, we can use race bar chart. You have seen race bar chart, for example, in different contexts. We can use transition when movement of data from one place to another one is important. We can use interaction when mouse over, clicking, or these kind of things is important in our visualization, or particularly in a dashboard. It's very important to consider um, interaction. Um, the next part of this talk is about design. Actually, when we create and we choose right visualization for our data visualization task, sometimes we are not sure what kind of design, what kind of colors we should use, for example. What's the best font that we should use for data visualizing? There are some best practice standards that I gather from a textbook, was written by an author who was a designer at Google. So one of the tips is most members of your audience will start from top left of your visual, right, to the bottom right. Consider this data flow when you want to visualize the data for the ranking, right? Audience, read top left to bottom right. Negative value left, positive values right. The design standard says leverage color selectivity as a strategic tool, right? Don't use color for everything. Just use color for what you want to be highlighted. Too much variety prevents anything from standing out. You can use blue, for example, color to signal positive or green, and orange or red for negative. This is how our eyes um, see the objects, right? On the left side, you see a heat map, right? But because we have various colors, right, we cannot concentrate on something that the presenter wants to mention. On the right side, we see that some cells are darker and some of them are not. So it seems that the presenter wants us to focus on a specific cells of this um, chart. Design with colorblind in mind. Roughly 8% of men and 0.5% of women are colorblind. They have difficulty in distinguishing colors. Avoid using shades, for example, in your visualization. Consider also using bold, varying saturation or brightness, or adding a simple plus or minus sign in front of the numbers when you want to show in a table. Um, Add a description that guides reader interpretation in the visualization. Use a legend or access label, for example, for data in the graph. Don't label data point all the data points. For the case of readability, just show the points that you want to be again highlighted. Text is your friend. Text plays an important role in communicating with the audience. Every chart needs a title. If there is a conclusion you want your audience to reach, state it, mention it in the graph. Thoughtful use of text makes the design accessible. It's clear to audience that what they are looking at, as well as what they should pay attention to and why they should pay attention, right? So on the right side chart, we can see there's a title and there is a label on the y-axis and there's a label on x-axis, data source coming from. Um, Font face, size, direction, and color affect the legibility. Avoid setting text vertically or at angle. Limit the use of italicize or boldface. Just use these two for example, title. Ensure everything on your chart is readable. If you are using chart in PowerPoint presentation, use a larger font. In terms of a scale, if you want to highlight something all right? These are the exception that you don't need to use a zero baseline because you want to highlight the trend or changes over the time. Avoid using 3Ds. It affects on the readability. Remove the grids, for example, in your visualizations. It's recommended that at most 10% of your visual design to be highlighted using bold, italic for titles and labels, case and typeface in short word sequence, and color in an effective highlighting techniques when it uses sparingly and general um, in relation to other techniques. Um, Inversing elements is an effective at attracting attention. For example, in table header, you can use inversing elements. Size is another way to attract the attention. Um, I mentioned about the size, for example, particularly in bubble chart or bubble map. Blinking or flashing is another way, but it's not recommended. Try to eliminate distraction from your visualization. When detail is not needed, just summarize it. Ask yourself, would eliminated this change anything? No, just take it out. Push necessary but not message impacting items to the background. Um, Light gray is a good color when you want to show, when you want to make something inactive in your visualization. For example, this is one example that shows the census data for American. As you can see, the visualization used the colors to show the years, and basically, it's not visible in the data. That's what the presenter wants us to conclude, right? We have different education in x-axis. We have all on the left side, and we have different numbers. But when we convert this visualization to the right side, we want to highlight the new marriage rate by education. So in the right side, we remove the all, for example, from the visualization. We highlight what we want to be highlighted. We remove some numbers that we don't want to see. On the right side, you see that the bachelor degree or more, it starts from 62 and with 57 in 2020. Now we see the years on the x-axis. So on the right side, you agree that this is a good visualization, right? So in general, don't overcomplicate overcomplicate your visualization. Use a straightforward language in the title, and like I said, remove unnecessary complexity in your data. Aesthetic is very important. The main lesson that we can get from is just use um, proper color for your visualization. Pay attention to alignment, organize the element on the page to create clean vertical. Uh, Always leverage the white space between the bars. For example, here we can see again, we want to compare US population and our customer, for example, in the company, and we want to highlight some parts. And here we use different colors, but here when we consider the standards, we highlight that segment 3, 4, 5 is important. From 30% US population, we have the 50% population in our customers. Don't use 3D because you cannot compare the slice sizes in pie chart. For example, in this picture, you can see this is a 31%, but this slice looks larger than this one, or here we cannot recognize the bars number. Um, the other thing is sometimes we use dual axis. This is good, but the better way is to use two different graph when we have dual axis. Either you can remove the y-axis or and put the numbers on the lines or bars, or you can have two different y-axis for the same scale. There are some examples of good visualization, why the, for example, the following line graph is readable because we can see um, the trends over the time. For example, this one, the presenter mentioned the conclusion in the graph. And here we can see stacked bar chart because of the limited time and I want to show Tableau software. I just fastly skip these slides and let's have experimentation with Tableau. So before going to Tableau, I want to mention that Tableau is a data visualization software, is one of the leading data visualization that we have. It's designed to integrate with the range of data sources. Um, it has interactivity, drag and drop interfaces, and it has robust capability for filtering, grouping, creating dashboards, and aggregation variables. And Tableau workbooks easily published on the web. This is the great feature that we have. Um, Let me open up the Tableau software. Um, this is the main point, the main entrance of Tableau. Tableau, by the way, is a commercial tool, but in academic, you can have a free license for 1 year and two. It's free for students, for teachers, right? In academic, so it has very good features. It has another tool named Tableau Prep tool that allows you to prepare data, clean your data. But here we have Tableau Desktop. The Tableau Desktop allows you to import your data and visualize your data. So at the beginning, you can see Connect on the left side where you can use different data sources to connect to um, different files or databases. For example, you can connect to a Tableau server. Let's consider that. Let's assume that you have a Tableau server and different place you want to connect to them. You can simply click on Tableau and you can connect to that server. For example, here on the left side, you can see we can connect to Excel file, text file, JSON file, PDF file. You can connect to server like MySQL server, Oracle, Amazon, Databricks, big data platforms, and there are other um, database connections that you can connect. For now, I want to um, import some data from Excel file. I have a sample Excel file and I import the data file here. When I import the data file, I can see on the left side three sheets in my data sets: orders, people, and return. When I click on each one, we can see the data exists on each sheet, right? And um, um, apparently there are some connection between the data set. Here, Tableau allows you to explore your data, see what kind of data set and data type you have. Here, you will see let me drag and drop the first data set. This data set is about a sample data set of a superstore, um, is a shop, including information about the customers and their orders, their dates, their shipment information, right? And here you can see a tabular view of your data set. It starts with a row ID and order date, ship date, and some geographical information of the customers, country, city, state. And above each column, you can see we have data type. When we click on that, you can change the data type of each one. For example, row ID, it says numbers. We have nominal data, right? And we have date and time. And we can see some specific information of data. If your data set is large, you can just show 1000 rows or any amount of rows that you want to show, right? If your data or fields include aliases or renaming, you can show here. Otherwise, you can just explore the data, but this is not the all the data that I have, right? We have 3 sheets. Um, Tableau allows you to connect the data here. So we have information about people. I drag and drop here, and it automatically recognizes that there is a data sets here that can be connected based on the region, because we have information about the people here, those people that ordered those products, for example. When I drag and drop another sheet here, it again recognizes the information and other data sets. But to connect the data effectively, the only thing that I need to do is um, double click on the orders so that I can be directed inside of the data sets. So in this way, it can be combined with the current data set, or it can be joined to this data set. So when I drag and drop, it says that these 2 data sets can be joined. And I click on the join, um, I can see there are different type of connection that we have. Here we have inner join, or we want to show all the common rows um, and all the rows in the left side data set or the right side data set, or we want to show everything, either connected or not connected data. I do the same for the returns. Um, and now we can see the data are connected automatically because the columns are defined. But if we think that this is something wrong in our data set and we want to change the columns that are connected to each other, we can change the columns here. We can see that in the left side data set, we have something that we want to connect. In this way, you can import different data sets and you can merge it or join the data sets here together, right? If you have 2 sets of data exactly the same, you can use union. So in this way, you can just drag and drop it under this data set. I don't want to do that here, but now I can see I have my data connection and I can see my data here that are connected to each other. We can see information about people coming from this data set, information about returns coming from this data set, and now I'm ready to visualize the data. So in the sheets, I can see that there is an environment that I can visualize data. On the left side, I can see the data source that I have. It says orders merge with sample, merge with the other data sets, for example, people and returns. And the left side, you can see different things here from orders, people, and returns, those data sets. Basically, on top, we can see the dimensions, nominal values, things that I can visualize that. And after that, we can see the other nominal values from different data set. In the bottom, we can see in the left side, you can see some numbers. So people bought something, a product, they have some discount, profit, quantity, and sale. And these are the fields that generated by Tableau, right? On top, you can see different menu. I don't want to go through all this menu, just want to show you how we can use Tableau for analytics. Let's assume that I want to see the product category, right? If we want to show the product category, we can drag and drop to 2 fields here, columns and rows, right? Basically, we show rows to show the metrics and columns for categories. And on the left side here, we can see filters to apply some conditions or filters. We can see some marks to highlight the data based on colors, size, text, or based on individual records that we have, or we want to show the tooltips, right? And on the right side, you can see the show me. When you drag and drop some fields, Tableau automatically recommends you some data visualization or charts. So let's do that. So I drag and drop a category on top. It shows I have 3 categories. I can show the number or the amount of sale per category here. Automatically, it creates bar chart. On the right side, I can see that some charts type are activated, right? So I can change it to some other types if I want, right? Like the stack bar chart or columnar bar chart or tree map, let's say, and some other things that we can see here like the heat map, right? But in any case, I switch to tables. I want to show categories. I learned that to show the categories, I can use a bar chart. That is good. But I have some categories as well. So I can see that in this data set, there are some furniture that their sale amount was almost $60,000, right? And I want to add another subcategory to here, and here we can see different categories. We have different categories: furniture, office supplies, and technology, right? But I want to see each category but by different colors. To do that, I can um, drag and drop subcategory to the marks in the colors so that I can see different colors in different formats. We have here the title of the chart, right? But again, this is not the best visualization that I create. I want to do some filtering so that user can select between the categories, right? To do that, I can um, drag and drop categories to the filters. And now this pop-up says which category that I can use. Do I want to use all the categories, or I want to filter some specific category based on wildcard, or a specific condition, or top categories, or top sales categories, right? For now, I just select all the data that I have, and I want to use this as an option for user that user selects from the category. For that case, I show this filter to the user. On the right side, you can see here the filter, right?
Yeah.
Yeah. So yeah, we can use, for example, multiple or single values dropdown to use between categories here, right? And another thing that we can do, this is one of the interface that we can create. Another things that we can do is using based on the maps. For example, if we want to visualize the data over map, um, because we have country here, we can drag and drop countries, and we can show based on the postal code. Um, just let me show you how we can do that. For example, here we have country here, and we have postal code, and we want to see based on the number of sales, and it automatically shows the type of the visualization that I can create here. I can use map, right? And if I want to switch between the categories, again, I can show the categories and switch between the categories. And let's have these categories here as well. I want to show you how we can use two visualization in Tableau at the same time. Again, the drop down here. And the thing is here, I can say apply this worksheet to use all these data sources. When we do this visualization, then we can see all the visualization in a single dashboard, right? So I think I created a dashboard here. When we selected that category, we switch between different categories, and automatically each subcategory can be shown here, right, at the bottom. So after creating several sheets, we can create one visualization or one dashboard. And for each dashboard, we can include a couple of visualization, and then we can create a story. A story allows you to have several dashboards at the same time. You can switch between different dashboards. For example, we can create dots or arrows, or caption boxes or numbers to switch between different dashboards, right? And another thing is I can add another, again, dashboard in my visualization. But this is This is the way that Tableau allows you to switch between the or to select one dimension for different values. Um, I don't know how much time we have, Ali. I can continue on this to explore.
Well, I'm fine. Like, go on as you need. Like, maybe, but if you want, we could just stop to see if anyone has questions. But if you wanna, I didn't see many questions there, so I answered some of them. But does anyone has any questions so far? Before we continue.
Well, yeah.
Yes.
Ask questions. Hi, thank you, Dr. Raja, for your nice presentation.
Yeah.
Yes, go ahead, Nasrin.
Well, okay, thank you. First of all, thank you for your nice presentation. And well, I have a question here because I'm new in data visualization. I am familiar with some tools like Power BI, but a bit Tableau. I know that in Tableau we can do some stuff with data warehousing and do some stuff with tables, connections, and so on. Can we do data warehousing in Tableau, and which one do you recommend?
Connection to data sources?
No, somehow I know that in Power BI we can change the connections between tables and do data warehousing. I know.
Yeah, it depends. If you want to connect to a server, for example, different servers, you can, in server, you can sign in different servers on top. For example, connecting to Databricks or data warehouses, you can sign into those ones, and here the published data sources will be will appear here. So and you can connect it. Otherwise, if you want to connect to a, for example, other data sources like you mentioned, for example, in Oracle or Databricks or Amazon, you can do this connection here. But regarding this switch between different data connections, right, if they are located in different places, you can switch based on even the list that you have in the list of servers that you define in servers section.
Thank you. I mean, if we have many number of tables here and we'd like to somehow manage that.
If you have more than one tables, all the data sources will be will appear here in the left side. Then when you want to switch between data sources on top, left top, you can see different data sources. So if I add another table or another database, I can switch between the data sources here. Right.
So here we can handle with key IDs, and for example, change the connections, define for example, this. I know that we can do this stuff with Power BI, but I don't know if it is possible with Tableau.
I didn't use Power BI inside of Tableau, but I used Databricks. I used MySQL files, right? And
Yeah.
switch between different connections, right? But I'm pretty sure that switching between the data sets that I have is possible on the left side top between the data connection. So I assume that if all the data that you have or tables are in single data sources or in single servers, you can add the data sources here, and then you can switch the data sources by providing the switch on the left side top by switching between the servers here.
Great, thank you.
Welcome.
Yeah, something that I could add is, so I work a little bit with Power BI. Yeah, I think as Dr. Rajavi mentioned, they're very kind of similar concept that you want to get access to the data, you want to visualize things, you want to create different dashboards, sometimes mostly live dashboards. And what Tableau also offer you the same thing that you get like in Power BI is the ability to create custom metrics. So if you want to, I don't know, like create like add fields, etc., you could definitely do that here. And in Power BI, there's also an option in Tableau that you could either use that data live or just get an extract of the data. So like sometimes you want to maybe connect to the dashboard, to the data once, extract some data, but you don't want to connect every time. You want to work on data, and then if needed, just update the data. Yeah, that option is available here. Yeah, okay, thank you. Any other questions from the audience? No, okay, so yeah, I'm enjoying, and I think this is a great learning opportunity. So yeah, let's go and learn more.
Yeah, there are a couple of things, Ali, that I would like to mention.
Yeah, sure, go ahead.
For example, I enjoyed the calculate field option or parameter options in Tableau, something that I used a lot for my visualization purposes. For example, if I want to create a new metrics here, and now we can see the categories and subcategories, and that's great. So I can switch between the categories, see different categories, and I can see the amount of sale, right? But at the same time, perhaps I want to see different metrics, let's say profit, quantity, and discount, right? What should I do then? Should I create another visualization for that? Or I can create a dashboard including dimensions and metrics close to each other? Or let's assume that I want to create a new field here, for example, sale over quantity, right? For that case, I can create a calculate field. I call it sale over, let's say, quantity, right? And here I simply define, here you can write some programming language, and here you can mention that sale over simply quantity. This is a basic formula that I write here, and it will be as one of the calculated fields here. So now instead of 4 metrics on the left side, we have 5 metrics, right? Now I want user to choose the metric, what the metrics wants to see, right? For that case, I can create a new parameter. So in this parameter, I want to define a list of metrics that the user wants to choose. For example, call it metrics list. In a metric list, the type of this is string, and it's a list of the metrics, okay? I simply define it sale, let us assume it is quantity. What else? Discount, right? Another thing is sale quantity, something that we define uh, recently, right? So now we have 4 lists, and this list can come from another field from this data sources. And I add it here, right? And now I know that I have a list, but how can I tell Tableau, hey, Tableau, when I choose sale, this is the sale, that same sale that you have here, right? For that case, I create a new calculated field. I call it metrics calculated field. And here say, if the user, let's say, choose a metric list sale, so I know that this is the sale, right? So here I call sale from this metric. Then else if, let's say this metric list is, let's say, quantity, all right, then select quantity or something like that and end. And let's have this just for these two fields and see this if it works or not, and we call it metrics calculators. And here, instead of having sale, I can use the calculated fields that I have here, right? So I remove the sale here and just have the metrics calculation that I have. And for the metrics one, I can use parameters. And in parameters, I can say show parameters on the right side. So here I can see on top, the user can select sale. So I define for sale. When I choose for quantity, it changes. And again, I can switch to sale. And if I want to add discount, discount should not work, right? Because we don't have anything in that. So for that case, we can go to the metrics here that we defined. We edited, again, we added else if, let's say, the metric parameter that we defined equals discount, right? And then show the discount. In this way, we can add the parameters, and you can see that we have a discount here. In this way, the user can select the category at the same time with the metric. Okay, so I want to create a dashboard for that visualization. And if I drag and drop here, I can see that on the top, we can see the metric list. And the category here, for example, sale and on furniture. What was here? And perhaps we don't need to show this card, and but we need to see the legend. Another thing that I want to mention is, okay, we make a category, we have a metrics list, right? And we have a legend, but what about the title? The title that we have does not show which metric it is. Is it a sale or discount or quantity? The cool things about Tableau is it allows you to make it a dynamic title. Here, for example, I say metric, and here we can insert the parameter metric list that now we have. Here it says sale, right? If I go back to visualization, I can see that here we can see office supplies, this is sale, and this is quantity, right? And at the same time, we can change everything. It's dynamically. So we don't need to create several visualizations in one place. We can use this parameter at the same time the filtering to filter the data that we have. The same things we can do for other visualization. I can continue this for hours, but I think that we have limited time. Um, and these are the things that I wanted to mention. Then you can change the layout. Um, like I said in my data visualization talk, we should tell a story finally to audience. And it's better to have a story here. Each story can have different dashboards, right? In one story, I want to show the categories. But when I want to show the categories, I want to see that, okay, in the chairs, we have more in the furniture product or furniture category. But at the same time, I look at the map to see that which region had top in sale, right? And when I switch to something else, so I can see the relationship between the subcategory and this map, right? And at the same time, we can change over the data sources. So we have one metric, but those metrics applies to two different visualization. So this is one of the story that I can tell to the audience. Okay, I want to show categories, subcategories over the map, right? And then I can create another story and see my data from different dimensions. And then there are a bunch of layout options that you have. On YouTube, there is a 6 hours tutorial, Tableau tutorial that people can watch regarding this visualization. But yeah, and like I said, this is a free license for academic, and students can leverage using Tableau. And like you mentioned, Ali, we can publish our data on a server. If you want to demo your work with the clients, with the other stakeholders, you can just publish your workbook on a server, and then other people can, at the same time, they can see your visualization. This is one of the best way to demo your work, right? And yeah, that's it from my side, Ali. I think that's 1 hour and a half. We catch
Yeah.
the time here.
Yeah, thank you very much. Thank you, Dr. Rajabi. Thank you, Nayat, for your great presentation. I enjoyed it. I was just sitting there and I was learning because I think this was one of the um, most thorough presentations that kind of like that talked about everything, like what is visualization and what is a good design. Like I wanted to ask some of those questions that you actually addressed in the second part of your visual the slides that well, what are the things that we should do to create a good visualization? Like, what are the mistakes that avoid? Because I really see that a lot of, I guess, students or people, when they create something, they make it colorful, they love colors,
Yeah, exactly.
play with the fonts and everything. Well, don't, like, just make it very simple. Don't use any, just use that amount of, I guess, like just put like 10% of your work into emphasizing a specific item rather than making everything colorful. So yeah, that is something that I really like. I learned a lot about. I really like that slope um, graph, a slope chart. So
Oh yeah.
that's something that I really liked, and I didn't know that it exists. And I've probably seen it, but when you put a name on something, then you have power over it and you could actually use it. And I think that's great. Wonderful.
Mm-hmm.
Um, so I leave it to the audience, like any questions from the audience. I think there was one question that I tried to answer. Um, but I think like you mentioned that, do you know between Tableau and Power BI, which one is more flexible and handy? But yeah,
Given
but
that
if
I
you
don't
haven't
have,
worked,
I mean, I worked with Kibana visualizations in the
mhm,
Elasticsearch, and ClickView. Each
yeah.
the Tableau's each visualization software has its own pros and cons, right?
Yes.
I started working with Tableau 2, 3 years ago. So I found this visualization very fancy, and you have I mean, I just mentioned a couple of features that you have, but lots of things over there. And like I said, there is another tool, a Tableau prep tool, that actually works for the preparation builder for data scientists that they want to prepare their tools. You can add different data sources. You can clean your data set. You can perform the statistical analysis. I didn't want to go through that, but Tableau Prep Builder has these options for you to prepare your data. And then when you have your data prepared, then you can include it in Tableau Desktop. So there are two different things, right? So you can define a data flow, and with data flow, it shows different cleaning aspects of your data set. For example, you can see what are the outliers in your data. You can fix your issue directly here. You can create calculated fields. For example, you can split your column to 3 or 4 columns. For example, you can write formula inside of this calculated fields. There are lots of features for cleaning and preparing data. That's a great tool that you can use actually, and you can manage the null values. For example,
Mhm.
the issues that I mentioned in my talk here can be addressed using the Tableau prep tool. You can group similar data. Sometimes you have missing text and you want to group the messy text to each other, or you can clean, you want to clean that data. You can do that easily using the calculated fields here. And lots of things, Ali, we can leverage using the Tableau prep tool. So basically, they created this tool because they believe that the Tableau prep tool should be different. There should be a different software for data preparation because, like as you know, it takes lots of time from data scientists just clean the data and prepare data. So that's why they created a new tool. So we created a tool, we created data flow here, and finally we have clean data sets. When we have that, we import the data set into Tableau desktop, and we can leverage all the visualizations features in Tableau desktop.
Okay, thank you for mentioning that. Yeah, I didn't know that existed. Was this when was that? In recent years, or
I mean,
probably?
I don't remember exactly what's the first version, but the
Okay.
last year I was using this Tableau Prep tool in my data
Hmm.
visualization class, right?
That's nice.
And then, yeah, I think that's a very good tool to cleaning data set and finally have data, clean data here, because here you don't have options to clean your data, right? Either
Yes,
you should use
exactly.
Python, your favorite programming language, or you use Excel or other tools. So you can use these two tools together for different purposes.
So do you know, yeah, that's great. That makes sense. Do we have to run that every time, or is it able to automatically run it when the data is updated? Um, is it a separate tool that we use it, include the data and save it?
Yeah,
Or then like if we each time that our data is refreshed, it could automatically go through this
that's a good
process.
question. I never tried that, but I see that there are some database synchronization features.
Hmm.
But most of the time, I just use that for data cleaning and export it in the data, and it export it in the Hyper extension or CSV. Um,
Okay. Yeah.
but I think that that's something that we need. We have a data set that are not clean. We want to do it, in an automatic way. Um, like I said, there might be some options, but I'm not aware of
Okay. Cool. That's great. So yeah, that might be like I know that like that might be one difference in Power BI. Like there are some tabs that you could do some of these things
that.
there, but now here you have a separate tool that goes, I'm sure, in more details than what we have there. Um, so yeah, you publish things online. There's something I wanted to share. Like I had a memory with like Tableau, and there was I figured out something that was interesting. So we had this dashboard that we created, and we wanted the user to manually refresh the data set,
Hmm.
like the database, original database, like send something to the server and
Hmm.
have a button there. But then, and we had difficulty creating that. But then we found a way to do that, and that was by adding it. There's an HTML kind of sheet. There's a section that you could add something HTML or website. We added that. Is like you see how one sheet here, two sheets here. We added an HTML sheet, and then we created a website that was shown just beside um, the visualization. And then
Hmm.
the user could see that it's load up it as if it was in the Tableau itself. And then we had buttons that allowed them to do something advanced. And then it played really nicely that you could have advanced feature here, a part
Hmm.
of a website here, do something that you cannot do just in Tableau, and then when the data is updated, your visualization was updated automatically. Because sometimes the users are using maybe they have to update things on their own server or
Hmm.
everything. Instead of going there into a browser, you could bring some of that here. Uh,
Just I want to add that I used
yeah.
this option. I published some
Hmm.
workbooks online, and when I was publishing that, when I signing now I cannot sign into that server, but there was an option there that you can automatically, based on the period, for example, 1 day or even hourly basis, your data
Hmm.
can be pushed to the server dynamically, and the user
Okay.
could see the latest information, the latest visualization online.
Okay. Perfect. Uh, Now that you mentioned that, I remember that there was a challenge and there was a thesis that one of my friends actually did that. He's now in Google. So if you want to share the visualization and if you want to share an interactive dashboard without sharing the data, um, is there a way to do something like that in Tableau, or is the only way to publish something in a server? Or like if I publish that online, is that publishing the data source and the workbook, or can I just share the visualization online, not the data with it? Or is it
Um,
something automatic?
I think actually I use um, the permission part of the data source. I mean, you can publish the data source, but not everybody can access to the data source. So you
Okay.
publish the workbook along with the data set, but you put limitation restriction on the data set so that no one can access to that data set, right, on your server, right? And the others can just see the dashboard, right? They are not
Hmm.
able to see the data sources by that
Okay.
restriction, right?
Okay, that's great. Yeah,
Yeah,
that's
this is something that I
wonderful.
use, and I think that it's possible to do that in Tableau.
Okay, that's awesome. Yeah, so I remember that thesis was, they mentioned that, yeah, if for some reason the data is lost, like we don't have any access to it at all, and we just have the dashboard.
Mhm,
So my friend created a tool that goes, and it was interesting and funny. Like it clicked on every possible option on the dashboard and took a screenshot, and
mhm.
then created a like a pseudo
Mockups.
simulation. Yeah, and then when you were clicking on those, any option, any combination of option that you wanted, it would show the visualization, and without having access to the data. And it was nice because if you have a very large data set, which is, I don't know,
Mhm,
maybe terabytes of data, and but the only part that you carry is like the visualization, then that enabled users to do that. Yeah, I think he published that paper and that tool like last year. So that's
Interesting.
something. Yeah. All right, cool. I
Cool.
really enjoyed this visualization. Any more questions from the audience? All good. So thank you everyone for joining us for this presentation. Thank you, Dr. Rajabi. It was a great presentation. I really enjoyed it. We really enjoyed it. I know, like, I teach some part kind of visualization in my data science course, but uh, it's nowhere near the detail that you go into, and like talking about each different ways that you could present different types of data, the do's and don'ts, and those design principles. They were awesome. And at the end, the Tableau, yeah, it's a great software that students can use. I usually have this problem with some of my students that when they work on a data set, um, um, it's hard for us to communicate between each other what's happening in the data set, what was the data that you were talking about, things like that. And I think
Mhm,
visualization is a great tool to summarize the data, to know, to identify a scope, like identifying the scope that we work
mhm,
on, because usually the scope is so wide, and like students or researchers get lost to these oceans of data, this big data. But with
mhm,
visualization, we could say, okay, instead of working on a whole country, let's focus on the part that might have the most interesting data. And then when you see it on the map, then okay, that's part of the data that we want to focus on, apply a machine learning tool. So I think this was really great. And if someone doesn't know anything about coding at all, they can just get access to the data, use Tableau to visualize it, and then get really high quality outputs.
Yeah, exactly. Like you mentioned, I think data visualization and visualization is an art, is not a kind of engineering. It's art to, it's your art to visualize something that the audience can enjoy, right? And the Tableau allows you to use a free tool before joining industry. For example, for their students, they can download it, they can test it with some open data sets, and they can, create some visualization as a practice, right? And yeah, I highly recommend the students, my students, to work with Tableau. They have some assignments. They created a visualization based on, and one of them published a paper with the visualization after having the course, right? So yeah, that's great. Hopefully, it's you enjoy the presentation. Hopefully, it is useful for the students, and
Definitely.
keep in touch.
Yes, definitely. Thank you very much. I like what you said about visualization being an art. I was thinking about it and I wanted to ask you about that, but just you said that. Yeah, it seems like it's more an art than an engineering. You need to, it's not just, okay, I've got some data, let's put it there. I should use bar chart and that's it. No, you have to get that sense of a human being, the person that you're telling the story to, how they're going to receive it, and then design a perfect combination that is not too detailed, that is not too simple. And that's definitely an art. So thank you for mentioning that. There's one question regarding recommending some Tableau certification. I guess, yeah, if you know any thing regarding that, you could answer. I just want to end the recording, and I want to thank you everyone again, especially like Dr. Rajabi, thank you for accepting our invitation.
Thank you for
Sandeep
having me.
Tandra, yeah, Sandeep Tandra, he really helped in organizing this event. Elnaz, he created the poster. Farhan, he helped in some of these design as well. So I want to thank you all the students that
Yeah,
help us in this. And yeah, thank you very much.
thank you very much of the students that and organizers of this talk, and have a good day.
Thank you. So
Bye.
I stopped the recording. Yeah.
Yeah.